Hello, my screen is visible. My screen is visible. So we are seeing about a pig architecture, Apache pig architecture. The language used to analyze the data Hadoop using pig is known as a pig Latin. So pig is, for example, you can know Apache pig is a compiler. Then we can say that Apache pig Latin is the language which we are running on. For example, Turbo C is there now for running a C++ program. So what we can call a C programming language. The Turbo C is in a software and language. So here also same as Hadoop using a pig is known as pig Latin. It is a high level data processing language which provides a rich set of data types and operators to perform the various operations and data. So before submitting data to the Hadoop MapReduce job, we are going to be submit the data to the pig Latin. Through the pig Latin, our data is going to be arranged in such a way. For example, I think yesterday, day before yesterday, we saw about how the data is arranging. So the way of tuples or way of bags are, how the fields are in there. So what is the atom in that? So everything we are going to be seeing. So how we are going to be arrange the data? What are the operations, various operations we can perform on the data, such that the data is to submitted to the MapReduce function, MapReduce program. Okay, so that is the use of this Apache Latin. So Apache Latin is a language, Apache Pig is a application. So in Apache Pig application, we are going to be use Apache Latin statements to run. Okay, so this one. So to perform a particular task programmer using a pig, the programmer needs to write a pig script using a pig Latin language and executes them by using a mechanism Grand Shell. I already told you we have three ways of running this Apache script. So one is a Grand Shell, and the second one is about using script dot pig. We are going to be save as a file. We can run as a file, and the third one you can use a UDF, no? User defined functions. How we are going. The same thing only. So the starting only the names are like this, and then later we will know that what. After execution of these scripts, we will go through the series of transmissions applied by the pig framework to produce the desired output. So what will be the use of this desired output? Where we are going to be use this desired output? The output of pig Latin is going to be submitted to the Hadoop MapReduce. Then the MapReduce program is going to be perform the what either maybe it is a word count or it may be a maximum temperature. What are the different operations we can perform on a particular data set? We can perform on. Okay. So initially the Apache Pig converts these scripts into a series of MapReduce jobs, and thus it makes the programmer job easy. The architecture of Apache Pig is known as below. So I will show you Apache Pig architecture. This one, Pig Latin script is going to be performed on Apache Pig. The statements are there. So how the statements are going to be by using a Grand Shell or Pig server. We have the various way of running this one. Then the data, that script, how it is going to be processed. So for that I show on how the process of compiler is going to be performed. Same here we have, for example, Apache Pig is a software. How the Apache script statements, Pig Latin statements, how it is going to be execute and produce the desired output. So for that all I shown in the last previous two classes also. So once again I will show you with a different model how it will be. So once again I will open how the compiler will shows. I already shown this one, even if so many of them often. So I want to show you again. Is someone answer whether my screen is visible? My screen is visible. My screen is visible.
Sir, sir,
Okay, thank you. So now see that I already told you how the compiler will take a major role in a programming language. So how the instructions we are given in a program, how it is going to be executed in line by line or page by page, whatever it may be. So as initial stage, the program is going to be done with the syntax checks. If the syntax checks is okay, then the program is ready to execute. Once the ready to execute, what is the main part of a program is we can say that any expressions are there, that expressions are the main part of the program. So one expression is there, how it is going to be converted to the high level language to low level language. So that we will see. For example, the first one is about a scanner. So this is known as a lexical analyzer. This is the part of a lexical analyzer. How the streams of characters, it is going to be stream and it is going to be converted into a tokens. So next one is about parser. This is about a syntax analyzer. So it is going to be do the syntax tree or parse tree. So we can have two names. We can directly call a parse tree or we can directly call a syntax tree also. Then another one is semantic analyzer, abstract syntax tree. Is there any a form of raw data is available? For example, simply we can say that constant data are available. How we are going to be perform this constant data with the identifiers? So is there any type checkings are available or not? Any type checkings are available or not? If the type checkings are there, how we are going to be do this type checkings? So by the semantic analyzer, the type checkings are going to be done. Okay. Then another one is about intermediate code generation. So this is the major thing which the every expression is going to be do, and the major operation is going to be performed here. So what is the major functionality of this intermediate code generation? So it is going to be produce three address code. So once again, I will share you again. Don't put sounds if you have. Okay. So this is the intermediate code generation. The use is generating the three address code. What is the meaning of three address code? Means to take any one statement, maximum three operands, maximum of three operands we are going to be used in a particular statement. Even if for that we have a reason for that. So even if we have a multiple operators in a one expression. So if we want to perform execution, how we can do? First of all, we can take one operation, addition. Okay, first two we are going to do addition, then we are going to be submitted to the next operator. That is the purpose we are going to be divided into a three address code. Three address code means maximum three operands in one expression. That means simply one operator is going to be performed on at a time. At a time, we can perform one operator operation only. Then it is submitted to the next operator. So then optimizer. The optimizer is we are going to be optimized. Is there any chance of reducing the number of steps from the three address code? We can reduce and we can generate the intermediate representation of these components. Then another one is code generators. That is the target code, how we are going to be generated. So the target code means it is nothing but the low level language which we are submitting to the computer. So in order to perform. So this is the assembly language we are going to be generated with the registers. In instructions we are going to be follow how we are going to be perform. The last classes I shown how it is. So rather than this, we have error handler and symbol table also. So it's already I told you, but you are not yet come across this subject, so that's why again I'm showing these basis of compiler. Okay. So if we have a representation, scanner is going to be scan, parser is going to be optimization, and symbol table is going to be. So this is the scanning the Lex image and how it is going to be converted based upon the white space. It is going to be taken as a new line or a tab space. It's going to be written as a carry and it is. So these are the simple. I think have you know this diagram? Have you know this diagram? What is this diagram? I remember NAP and DFA diagrams, starting state and final state. So that is it. Simple. If we have any expression, how it is going to be followed. So how it is going to be divided. Context free grammar. And these are very so how we are going to be perform derivation tree. For example, we have the output of, for example, you can take any regular expression. So if A here we see that A B A A B B. If you have an output, how this output is going to become? So see that A B, then we can come A B B B. So here E is there, no? It is not E, it is another symbol. Okay, empty. This is known as an empty. Okay, like that we can read all those things by using one expression. If you remember the flat, we have context free grammar. S tends to A B B. We can remember. So we may have another derivation how we can solve that. So for that we have a grammar for everything. So in order to move the grammar, so for example, this is the grammar. So in order to perform addition and multiplication, this is the grammar. How we are going to do. For example, if we consider y plus 4 into z. So how we are going to be perform this job? See that first we are going to be, we may have two types. Maybe you can perform a plus operation or my star operations. So based upon. So if you perform plus operation, how it will be? So that's why this confusion known as ambiguity. So if you have an output that is a 4 plus y plus 4 star z, so that one we may solve in a different ways. If the different ways are there, the compiler may get the confusion. So in order to overcome this confusion, we have to eliminate this one. We have left recursion, left factoring concepts are there. So this is the confusion. If these confusion known as in grammar naming, we can call as ambiguity. So how it is ambiguity means? So once we have a different way of execution with the same sentence. So different way of execution. So for example, see here, if we consider a plus, so we are going to take it as E tends to E plus E. We can consider this one and we can, for example, you can consider star, E tends to E star E. We can consider. Later, whatever it may be, the final answer, we can get it any way. So that is the way we can. So that is the name called ambiguity. So in order to overcome this one, we have a lot of things. It is a very big one. Okay, we'll go to our main things. So that is where how the one programming language, how the okay. So how same if we have a big Latin scripts are there, how the script is going to be transferred into a parser, optimization, compiler, and submitted to the execution engine. So these are the phases of Apache. Okay, so these are the phases of Apache. So then the output, desired output is submitted to MapReduce, and it is going to be performed on Hadoop system. Okay. So here the first one is about parser. It is going to be check the syntax errors, type checkings on the miscellaneous checks on the. So here only we need to know about what is the direct acyclic graph. So here the direct acyclic graph you want to draw. Here we have three rules to draw a direct acyclic graph. So leaf nodes are represented with the identifiers, names, and constants, and interior nodes are represented as operators. And interior nodes also represent the result of an expression or identifiers or names, whereas the values are to be stored and assigned. So these are the simple examples. So how to draw in a direct acyclic graph. So I will explain the first one. T equal to A plus P. Here we have T0 is going to be stored the result of A plus P. So that's why only A and B are the identifiers. A and B are the leaf nodes. And which operation we are going to be perform addition operation, that I am going to be mentioning a root node. Then the result I am going to be shown in the beside of this root node. So that is the result. So first point is about identifying the identifiers and make it as a leaf nodes. And the operators are going to be mentioned in root node. And the result of that one, we are going to be mention it separate beside itself. So that is the three rules. So is there, leaf nodes are represented as identifiers, names, and constants, whatever it is. The interior nodes are represented as the operators. The interior nodes are also represented the result of the expression or the identifiers or names where the values are stored in assignment. So where we are going to be doing simple assignments in equal to how. So then optimizer. So another step is there. No, first one is about parser. The second one is about optimizer. The logical plan DAG is going to be passed to a logical optimizer, which carries out the logical optimization such as projections and push downs. So how we are going to be optimize, how we are going to be reduce the number of steps from the 3 address code. Then the compiler. The compiler compiles the optimized logical plan into a series of map reduce jobs. So how we are going to be reduced, we can perform. So that logical plan we are going to be submitted to the map reduce. Then execution engine. The map reduce jobs are submitted to Hadoop and in a sorted order. Finally, these map reduce jobs are executed on Hadoop producing the desired result. So that is a final output of map reduce. So the execution engine is going to be submit the desired output of pig Latin script. Then it is going to be finally done on map reduce jobs and executed for Hadoop producing the results. The final. So here we have data models are there. How the data models are there in the pig Latin. So the data models of pig Latin is fully nested, so fully covered. So if you consider one data, we can read it from anywhere. So we can, for example, in the downside we have DAG and it is visible now. So in the, for example, this is a set of data lines are there. For example, you can consider this is a data set. How we are going to be read the data? By the tuples we may read, by the bags we may read, by the fields we may read. So it is fully nested and it is allows to complex non-atomic types such as a map and tuples, which are given the diagrammatical representation shown. So here the non-atomic. So then what is atomic? So atomic is nothing but a single part, a single value in the pig Latin, which is represented as atom. So what is atom means when particular field, one particular field. For example, in Excel sheet we can known as a one particular cell, no, the cell value. So same here we have a particular field is known as a one is single. So tuples are recorded. It's going to be stored. A set of fields is known as a tuples. The tuples can be any type. A tuple is similarly similar to a tables of rows in a tables of RDBMS, relational database management table. In one single row, how we are going to mention same. So example, Raj, so we are going to be mentioning normal brackets. So then another one is about bags. The bags is an unordered set of tuples. So in other words, each collection of tuples, non-unique, is known as a bag. Each tuples can have any number of fields, flexible schema. A bag is represented with flower braces and is similar to tables in RDBMS here also. So why we are everywhere we are considering as RDBMS, RDBMS, RDBMS. So where I told you in the starting itself, pig Latin is similar to SQL. So SQL means where we are going to be in database tables only, we are going to be using SQL statements in order to compare the table, in order to combine the table, in order to join the table, in order to find out, in order to show the table at a user side. So everything SQL statements we are going to do. Same here also. Same RDBMS tables where here the data is going to be nested such that these statements when rectify the here the big Latin statements, the script is going to be read the data from the data set. So here we may know the another concept about inner bags also. So we may represent inner that in nested we can have bags inside another bag. So that is known as a inner bag. Then another one is about map. Map, whenever the map is a key value pairs, so we need to remember key value pair. The keys are key needed to be the part of a char array and it should be unique. The value might be any type and it is represented by square brackets. For example, this one. So how we are going to do it. So Raj is a key and that is a value. So again here we need to remember that the keys are unique. Then the relationship, how we are going to be maintain the relationship in the and the relationship is a bag of tuples. The relationship big Latins are unordered and there is no guarantee that the tuples are used in any particular order. We don't know how we are going to be call it. So based upon the big Latin script statements, how we are going to be called. So then the another important thing is how we are going to be run this one. Big software, for example, you can go it is a one application how we are going to be running. So for running we have two modes. One is a local mode, another one is HDFS mode. So local mode in simply we can execute one statements and we can do it local itself. Here there is no need of HDFS. Hadoop system is no needed. Then we can collect from the data and we can store in a local itself. In the local files itself, we are going to be call it and we can execute the statements directly without the help of any HTTP. So that is one. Another one is the local mode, another one is the map reduce mode. See that first one? In this model, the files are installed and run from your local host and the local file system. There is no need of Hadoop or HDFS. The mode is generally used for testing purpose. So local mode is going to be used for testing. So before going to be perform on full operation on a big Latin statements. So it may be you can simply call map reduce mode in order to execute before. We can test whether the statement is going to be produce the desired result or not. For testing purpose, we can check it. Then once the test is confirmed, then we can directly go on the map reduce. So here the map reduce mode where we can load and process the data that exists in HDFS file system. So that is distributed file system. The data set is contained. We can directly apply now using Apache Pig. In this mode, whenever we execute the Pig Latin statements, process the data, and MapReduce jobs are invoked in a backend to perform a particular operation on the data set that exists in HDFS. So this is the one part of HDFS. So if Apache Pig running, how we can run that application? Once we run, we are going to be used in Apache Pig, Apache Latin statements. So how we are going to be run this Apache script, Apache Pig script, how we are going to be run. So there is another 3 ways of running this script. So for this only I ask you to remember the Python how we are done. So simple one statements we can directly do. Another one we can use the .py. We are going to be save the file and we are going to be execute. Then we can do in functions which we are going to be write it for our own and we can perform it. Same way here also. Here the 3 modes are there to run this one. So one is the interactive mode, another one is a batch mode, another one is a embedded mode. So interactive mode, batch mode, another one is embedded mode. So interactive mode is going to be called as a grand shell. So this is one part of Apache Pig where we assign the architecture also if the grand shell is to the grand shell. We can run Apache Pig interactive by using a grand shell. So there is to enter the Pig Latin statements to get the output itself by using the dump operator. So we can have only one statements we can run at one year time and we are going to be finished the operation. That is the interactive. Then another one is about batch mode. Here the whole statements are, for example, we are writing all these statements at one time. So that is the see that you can create a file. That file we are going to be use a .pig as an extension. So in order to computer to recognize that a particular file is a Pig Latin statements are compiled. So for that only we are going to be use .pig as an extension. .pig as an extension. Okay. Then another one is about embedded mode. Apache Pig provides the provision of defining our own functions, user-defined functions in a programming language such as Java, and using them in our own script. So in order to make own data, how we are going to be writing a functions. So how to combine by own. So any predefined functions rather than that here we are going to be use your own functions to perform an operation. There we are going to be use this embedded. Interactive mode, batch mode, and embedded. These three modes are there to run the Apache Pig scripts. The previous one is about local mode and MapReduce mode are the running the Apache application. So please be for the both. Then here the first one how these commands are going to be in a grand shell how we are going to be. Here we have once we have command then local system Apache Pig is going to be run. Once it run it's going to be shown as grand. So grand greater than symbol. So that is it is ready with to run the pig statements, pig script statements it's running. So in order to close the shell, we can use control plus D, we can close the statements. For example, you can see how the statements grant customer load customer text using pig storage the command. So these are the lines we are going to be using Apache Pig. So executing Apache in a batch mode, there we are going to be save the total scripting lines into one file, one single file. So that is a sample underscore script.pig. So for example, how it will be where we have a number of statements. So the ending with dump, for example, dump operator, the dump we are going to be used to end. For example, what are the operations we are going to perform? Finally, we are going to be closed. So once the file is ready with you, then how we are going to be run. So in a local mode, we are going to be run $pig -x local sample script.pig. And the another one is MapReduce mode. We can use MapReduce sample underscore text image. So this is the two different modes how we are going to do. So here we have so many conversations are there, conventions, naming conventions in map where we have I think generic types. So we are going to be when we are learning about Java generics, we saw about naming conversions. What is T? What is E? P is a type. E is the element. S is the secondary element. U is like that we learn. Same here also we have some naming convention. That is simple meaning. So what is the particular representation we have to do? For example, we are giving a parenthesis brackets. So what is the use of a parenthesis? So parentheses are used to indicate the tuples data type. For example, square brackets. What is the use of a square brackets? In order to mention the map data. For curly braces, curly brackets, in order to mention the bag data type. So these are the data type. Then we have O, P, Q, R, S, T, U, V. So everything we have on schema for O, on schema R, order, or output, or outer. And P we have a parallel pig, pig dump, and pig storage and password. So the various names are starting. You can easily remember that what is the things are. These are the naming conversions. So then here we need to know about the case sensitive, how we can write. So how the names are going to be mentioned in pig application. Same way we have to use. So the names, yes, the relationships are case sensitive, and the big Latin functions are case sensitive. The names of parameters or big other big Latin keywords are case insensitive. So maybe you can use what are the reserved words, keywords are reserved words, maybe are insensitive. Maybe you can use a capital letter and small letter. So only the keywords are may you can use small or capital, but relationships are case sensitive. Namings in big functions are case sensitive. Other parameters and other keywords are insensitive. So in this example, we can show that so A, B, C are the case sensitive, and the F1, F2 are the case sensitive. For example, if you mention a small letter, then maybe you can use a small letter. Here the A, B, C are the capital letters. That is a relationship you have to mention in a capital letter, and the fields you have to mention in a small letter. So this is a case sensitive. Definitely you have to mention like this. For another third one is there no keywords. So keywords may you can use capital letters or may use a small letters. That is known as insensitive. So we don't have any particular. We may use a capital or we may use small. Okay. So that is a thing. So here we have, for example, this is a grand shell. If we have lines, how to run it. For example, A is a load and B is a root to write and C is a for each and B is generating count. How we are going to be running the grand shell, each big Latin script statements. So then how we are going to do this. So these are the things. Up to this we were discussed in the last two classes. I think so many of them not yet present in the last two classes. So today we will have 10 minutes. Little bit we can complete these data types and we will follow up to next class. So what is a data type? So what are the meaning of data type? So out of data types we have to mainly we have to know about identifiers. What is an identifier? So if you write something on a program, so if the user or programmer wants to know that what is that? So identifier include the names, relations, names of relationship, fields, variables, and so on. So for example, if I am writing something, for example, int A. So what A is identified? So whether it is identified as a keyword or what identified as a variable, identified as whatever it may be, that the things we are going to be mentioned by using this one, identifiers. So in Pig, identifiers start with a letter. So there is for mentioning identifier in a Pig Latin. So we have same. What are the rules for declaring an identifier? No? If you remember that, same here also. We have some of the rules are there to declare identifiers in a Pig. To start with the letters and can followed by a number of letters also or digits or underscores. So for example, what are the valid identifiers? We can start with the capital A. So this is a valid identifier. A123 is a valid. A small ABC underscore 123 underscore BX something we can do like this also. But have you remember there we can start with the underscore is a starting of identifier. But here we are not going to be considered underscore is a starting. So underscore is also emitting here. Underscore A123 also invalid. ABC underscore dollar symbol also invalid. ABC that is a special keyword, special characters. No, special characters are not allowed. As usual, same in our identifiers. The special characters are not allowed. Same keyword. So in between also the special characters are not allowed. This is the valid identifier. Here it is the invalid. So a relationship bags and tuples and pigs. A Pig Latin statement works with the relations. The relations can be followed, defined as follows. A relation is a bag, more specially an outer bag. A bag is a collection of tuples. A is a tuple is an order of fields. So out of this, what you understand these statements, for example. So bag is a big one. Inside bag we have a tuples. Inside tuples we have number of fields. Number of fields contains atoms. A single data, a piece of data. So that is the simple. relationship between these three words: bags, tuples, and fields. Fields అంటే ఒక single atom, one single atom fields అంటాం. A group of fields we can have a tuples. A group of tuples we can have a bag. That is. So a big relationship that is a bag of tuples. A big relationship is similar to a table in RDBMS table where the tuples are bag corresponding to the rows in the table. Unlike the relational table, however, the big relationship does not require any tuple contains same number of fields of the same position or columns. We have a same columns. So we don't have any columns information. So here we may have, for example, if you remember that data model, it may have different columns also. We don't have any proper column identification. We don't have. So only here we have row identification. So that was the end of today. So if you have any doubts, you can ask me. So let me tell you. So this is the big Latin architecture. So today's topic. In that we learned about what is a parser, what is the optimizer, what is a compiler, what is an execution engine. So if one big Latin script is there, so what are the things we are going to be used? So what are the valid identifiers are we are going to be mentioned? So what is the relationship between a bag, tuples, and the fields? What are the relationship we are going to? So anyone having doubt, you can ask me.